Hello everyone. Today I want us to discuss how we can solve simultaneous equation using matrix method. And this is one of the easiest methods of solving simultaneous equation. And we are going to use one example here, that is 2x plus y is equals to 5 and x minus y is equals to 1. So the first step, we need to write or express our equations in form of matrix. So step number 1, let's arrange or write it in matrix form. So we are going to take the coefficients, that is 2. Here, that is the coefficient of x, the coefficient of y, that is 1, the coefficient of x in the second equation, that is 1, and negative 1 for y in the second equation. So take only coefficients. So we have 2, 1, 1, negative 1. You close. Multiply with the another is x, y is equals to 5, 1. Like that. That is the first step. Step number 2, you find determinant. So we are going to get the determinant of this part, that is 2, 1, 1, negative 1. Determinant. So we're going to multiply the leading diagonal. This is called leading diagonal. Then the other diagonal we subtract. So you say 2 times negative 1 minus 1 multiplied by 1. So this is the same as we're multiplying 2 by a negative 1. So it gives us negative 2. And then minus, we have here positive 1 multiplied by positive 1, so minus 1. So our determinant is going to be negative 3. The next thing here is to find the inverse. Let's try to get the inverse of our determinant. So we know, given a value, let's say a, to get the inverse of a, you say a negative is the same as 1 all over the number, that is a. So in our case here, we are going to say our negative 3 is going to be 1 all over negative 3, which is equally the same as negative 1 all over 3. Now that is the determinant, but you have to know that when you take the inverse multiplied by the determinant, it gives identity. So when you say inverse times the determinant, that is a, it should be so multiply with x, y here should be the same as a inverse times a times what we have here, that is 2, negative 1. Sorry, we are going to interchange the inverse of a, that is negative 1, 2. Then change the signs here. The signs here should be negative 1, negative 1. Alright? Times what we have on the other side, that is 5 and 1. Are you there? So this is going to give us the identity. So x, y is equals to inverse that we have there is 1 all over negative 1 all over 3, or negative, just say negative 1 all over 3 into 1, negative 1, negative 1, 2, multiply with what you have, that is 5 and 1. for us to get the solution of x and y. We are interchanging this. You interchange the leading diagonal, that is that is 2 and 1, and then change the signs of the remaining. Change the signs of the remaining. Now from here we multiply. You take this, multiply with this. So just say -1 all over 3 into 5 times 1. 5 times 1 is the same as 5. So 5 minus 1. 5 minus minus 1 should be minus minus will be plus 1, minus there. So this path is the same as -1 times -1 times 5 is going to be -5, minus -5 plus 2 should be -5 plus 2, positive 2. So it's going to be the same as 1 all over -1 all over 3 into -1 all over 3 into, this one will be it should be 6. Should be 6. It should be 6. Remember this was negative, sorry. Should be -6, because this one is negative. Should be -6. Should be -6. Sorry, -6. And this other part should be this one, and the other one should be 3. -3 x y there is equals to that. So x y equals to, so the other one will be -1 over 3 times 6. It gives us 2. The other one is the same as -1 over 3 times -3 should give us 1. So in this case, x is equals to 2, y is equals to 1. So that is how to apply matrix method in solving simultaneous equations. Thank you very much. Let's meet in our next discussion.